All right. It is late. This is Dr. Wright. I am going over everything equivalent fractions. As you can hear, my voice is a little coarse because I am not feeling too hot, but I wanted to make sure my fourth grade students understood fractions. And maybe you're in my fourth grade class right now, or you're just somebody who's trying to learn about equivalent fractions. I'm gonna go ahead, get started, get straight to it so that this video does not end up being too long. Now, the first two fractions that are at the top, we have 1/4 and 3/4. If I wanted to make an equivalent fraction, all I have to do is multiply the top and the bottom by the same number. So multiply the numerator and the denominator by the same number. It does not matter what number you use as long as it's the same number in the numerator and the denominator. And as you can see, 1 times 2 is 2, 4 times 2 is 8. That means 1/4 and 2/8 are equivalent. Now let me go to my next example. I just change colors as I'm going. If I want to make an equivalent fraction for 3/4, the rule is multiply the numerator and the denominator by the same number. You can also say multiply the numerator and denominator by a fraction that is equal to 1. That means the same thing. 5 over 5 is the same as 1 because 5 divided by 5 equals 1. Here in this example, 3/4 is equivalent to 15/20. Now, moving on, look at this model. And again, I'm going to go quickly, but you can slow it down, pause it, all that good stuff. Draw an area model to solve each problem. Draw an area model to solve each problem. Okay, I've already drawn a rectangle that's in eighths and one that's in fourths, and that is representing these two fractions, 2/8 and something fourths. I'm trying to make them equivalent. So I'm going to shade in 2/8. Now, I'm not going to fully shade it in because I'm just tired. And excuse my raggedy numbers, you guys. I'm doing the best I can, all right? Some of my numbers look like they are going through something. So we have 2/8, and now I'm going to shade in something on the fourths that's going to make it look the same as 2/8. If I shade in only one box, wouldn't you say that this takes up the same exact space as 2/8? Yes, it does. So they're equivalent. So I know the number I would put in here would be a 1 because 1/4, when you shade it in, takes up the same amount of space as 2/8. You can draw models with any fractions to figure that out. Now, here at the bottom, keep in mind you can also multiply to find your answer. Make your smiley face. This is the same exact fraction above, but you don't have to use a model. You can use multiplication to figure it out, or division. In this case, I'm going to use division. I'm going to say 8 divided by what number gives me 4? Well, I know that 8 divided by 2 equals 4. So that means I don't have a choice. I have to use that number at the top. 2 divided by 2 equals 1. And as you can see, you get the same the same exact answer. All right, so I'm moving on to my next slide. Look at this top number line. It is currently written in fourths. How do I know that? I can count my spaces and I can see. I can choose to do it this way. I can count one space, two space, three space, four spaces. I know that my denominator is going to be a 4, or I can say it is in 4 equal sections. I can make a loop as well. I can go 1. Oh man, you could tell I'm tired. Wow. 2, 3, and 4, which tells me there are 4 equal sections. Now, what if I wanted to make this be eighths instead of fourths? Okay, well, I'm just going to cut them in half. If I cut them in half, I'm gonna have eighths. How do I know? Look, I'm just gonna do some loops. Watch. 1, 2, 3, 4, 5, 6, 7, 8. Okay, just like that. So I just want to show you that you can break your number line into anything you want to. I can make it sixteenths. If I wanted to make it sixteenths, then I would put a line there and a line there. I'd put a line here and a line here. I'd put a line here and here and here. And now it's in sixteenths. And we can go on and on and on. Let's look at this one here. What is this fraction? Well, first I have to determine what my denominator is going to be for this specific number line. How do I do that? I count the spaces. 1, 2, 3, 4. Remember, I can also count it like this. 1, 2, 3, 4. So I know that this red dot, I know that the denominator is going to be 4. What's the numerator? Well, I just count the actual spots. I just count the spots. And I start at 0, but you don't count 0 as 1. 0 is 0. And so this next point is 1. This next point is 2. And the dot will fall at 3. So this will be 3/4. Here, I want to make equivalent fractions, but I want to do it using division. Same as multiplication, just a different operation. I can use any number I want to, and why not use the easiest number? And I know I can use 2 because 18 and 24 are even. So I know the number 2 is going to work. The number 3 works as well, but again, I'm going to use the easiest number I can find. 18 divided by 2 is 9. And 24 divided by 2 is 12. So I know that 18/24 is equivalent to 9/12. So now let me look at 9/12. Now for 9/12, I'm not going to use a 2. Why? Because 9 and 2 are not compatible. 2 is not a factor of 9. It won't work. 2, number 9 is a odd number. So instead, I'm going to use the number 3, the next easiest number. And I know that 9 divided by 3 is 3, and 12 divided by 3 is 4. Again, I'm going through it kind of fast, but you can pause it and you can slow it down and you can take your time to get through. Now, here we have something very important. These are called benchmark fractions. You just need to memorize it. You need to know how they look. This is how 1/4 looks. 1/3 looks like that. 1/2 looks like that. 2/3 look like that. Do whatever you have to do. Make a song about it. 3/4 look like this. Just memorize them. These are called benchmark fractions, and they help you compare fractions when it's just another method you can use to compare fractions. And again, remember, I am zipping through this video, but you can pause to take a minute to think, slow down, and understand what I'm doing. Decomposing a fraction is the same as breaking it down. So if I were to break this, first of all, is this fraction greater than 1? Yes. Anytime your smaller number is carrying the bigger number around, then it is definitely greater than 1. 2 is carrying around big number 6. That lets me know this is greater than 1. So improper fractions are always greater than 1, proper fractions are less than 1, and fractions with the same numerator and denominator are equal to 1. Now watch me break this fraction down. I know that 2 over 2, I can pull that out of 6 over 2. And you might be saying, what in the world are you doing? Watch. Watch me keep going. I'm just breaking it down. 2 over 2, that's 4 over 2. And guess what? If I pulled out one more, 2 out of 2, well, guess what? I know that 2 over 2 equals 1. I know that 2 over 2 equals 1. And I know that 2 over 2 equals 1. So therefore, 6 over 2 is the same as 3, which is correct because 6 divided by 2, remember fractions are division problems, and 6 divided by 2 is 3. But what if I made this a 7? Again, remember, I'm decomposing fractions, I'm breaking them down. The reason first of all, your denominator is always going to be 2, right? You can't change that. So I'm going to put a 2 in my numerator because what I'm doing is I'm breaking down this 7. So you might say, well, why didn't I pull out a 1? Well, I know 2 over 2 equals 1. So I'm going to pull that 2 out. So now I'm still left with 5 more that I have to pull out. Here we go. We have 2 over 2. Again, that's 2 plus 2 is 4. I'm going to keep going. 2 over 2. That's 6. Wait a second. I only have 1 left. So that one is going to be 1 over 2. All I'm doing is breaking down my numerator. Your numerator that you break down should never be greater than the denominator. That's why I chose the number 2. I chose the number 2 because it's the highest number I can pick. So 2, remember, you don't add your denominators. Never add your denominators. Your denominators stay the same. But go ahead and add your numerators. 2 plus 2 is 4, plus 2 is 6, plus 1 equals 7. So you know you've done it correctly, but I'm not doing all of that just to add it up again. Let me scratch that out. What I am going to do instead is I know that 2 over 2 is the same as 1, and I'm bringing down my plus sign. 2 over 2 again is the same as 1, and I bring down my plus sign. Boy, this mouse is so raggedy today, okay? 2 over 2 is the same as 1. And then finally, I bring down 1 over 2. So now I'm going to add these up. 1 plus 1 plus 1 equals 3. And 3 plus 1 half equals 3 and a half. I have decomposed this fraction. Better yet, I have changed this fraction from a improper to a mixed fraction. Final one. Hang in there. Almost there. You have to say, are these true? Now, this is going to require some critical thinking. You just have to look at each one and figure out what they're saying. Is it true or not? Now, let's look at 4/5 and 5/5. We know that 5/5 is the same as, that's supposed to be an arrow, okay? 5/5 is the same as the number 1. Well, 4/5 is less than 1. So I automatically know that this is not true because 4/5, this one right here, is less than 1. Remember, proper fractions are less than 1. What is a proper fraction? The numerator is smaller than the denominator. So this is not true. Let's look at the next one. 40 over 80 and 1 half. This is true. Why is it true? Because Whenever your numerator is half of your denominator, it is considered to be halves. Anything, you could put a million over 2 million, it equals to one half. It is equivalent to one half. Whenever your numerator is half of your denominator, it equals one half. Now let's look at 3/4. Well, okay, I see 3/4. That's a proper fraction. So I know it's less than one, but look at 5/3. That's an improper fraction, which lets me know it's greater than one. So therefore, 3/4 is most definitely smaller than 5/3. And finally, 7/2. I know whenever the smaller number is carrying the bigger number, that this fraction is greater than one. But wait, that's not enough for me because the fraction 1 and 9 tenths is also greater than one. So then what do I need to do? I'm going to turn, I'm going to break this down so that it can look like a mixed number. How do I do that? You go 2/2. Remember, you're going to keep adding it up until you use all of your numerator. You have 2/2. And all I'm doing is I'm looking at my numerator. I'm adding up my numerator until I get to the number 7. And your numerator can never be bigger than your denominator. Look, I'm currently at 6. I have one more. I can't put another 2. If I put another 2, that's going to be 8/2. So I have to put a 1. And now when I add these up, I know they're going to be 7/2. And I know 2/2 is the same as 1. And so I'm going to make all of these ones. And then I'm going to bring down 1/2. And when you add 1 plus 1 plus 1, you get 3 and a half. So now I could compare these fractions. I know that 7/2 is the same as 3 and a half. And if I compare my whole numbers, 3 is bigger than 1. So therefore, this is true because 7/2 is greater than 1 and 9 tenths. Thank you for taking the time to watch this video. I think this is one of my longer videos, but I covered a lot of equivalent fractions. Have a great night. I'm going to bed. I'm so tired. I'll see my class tomorrow. And if you're not in my class, hopefully this just helped you to do some fourth grade math. Dr. Wright signing out.